Okay, next question's on probability. We've got a situation where we've got different types of sandwiches on a shelf, and here are the sandwiches, and we're going to take two of these sandwiches at random. Now, the way this problem is set up would seem to make us think that we're going to pick a sandwich and then pick another sandwich, so we couldn't pick the same cheese sandwich twice. So this is without replacement question. So let's think about it as a probability tree diagram, as most of these questions look like. So I'm going to say that this is going to be my egg, this is going to be my cheese, and this is going to be my ham, and I can associate probabilities with these because I know that in total we have 11 sandwiches. 4 of those 11 sandwiches are egg, 5 of those 11 sandwiches are cheese, and 2 of those 11 sandwiches are ham. Now, after our first pick, we're going to pick for the second time. Or we could pick here, or we could pick here. Egg, cheese, ham, egg, cheese, ham, and so on. Now, carefully we have to fill in the probabilities, because if I choose an egg sandwich the first time, if there were 4 of them to pick from the first time, there are only going to be 3 of them to pick from the second time. And there's not going to be 11 sandwiches left anymore. I've picked one of them, there's only going to be 10. If I pick an egg sandwich the first time, well, obviously I've still got the same number of cheese sandwiches. There's still 5 cheese sandwiches. However, there's only 10 sandwiches left. And similarly for the ham. We can then do the same and fill out the rest of the probabilities. So here I have 4 out of 10, 4 out of 10, and 2 out of 10. And finally, 4 out of 10, 5 out of 10, and 1 out of 10. We want to work out the probability that she takes 2 different types of sandwich. 2 different types of sandwich. So let's have a look at all the ways that we could pick 2 different types of sandwich. We could have egg and cheese, we could have egg and ham, we could have cheese and egg, we could have cheese and ham, we could have ham and cheese, or ham and egg. Quite a lot of probabilities that we'd have to work through. So you can either go through and work out what each of those probabilities are, or we can notice that actually we've got a difference, we've got fewer of them left. So if we pick the same sandwich twice, well, what's the probability of us picking the same sandwich twice? So we could pick egg and egg, which would be 4/11 times 3/10. We could pick cheese and cheese, which is 5/11 times 4/10. Or we could pick ham and ham, which is 2/11 times by 1/10, which is 12 110ths, 20 110ths, and 2 110ths. Now, this is absolutely what I didn't want to happen, because we wanted to work out the probability that she takes 2 different sandwiches, not that she takes the probability, not that she takes 2 of the same sandwich. The probability that she takes 2 of the same sandwich, all of these added together, is then 34 out of 110. That's not what I wanted. I didn't want the probability that she took 2 of the same sandwiches. However, the lovely thing with probability is that I can remember that probabilities must sum up to make 1. And if I didn't want these 34 events out of the 110, I can be pretty damn sure that I did want the 86 events out of 110 that are her picking 2 different sandwiches. So here's my final answer. It's going to be 86 out of 110, which I obviously will simplify to make me 43 out of 55. Now, as I say, we could have gone about this by finding all of the probabilities and adding them together, so finding 4/11 times 5/10 plus 4/11 times by 2/10 plus 5/11 times by 4/10, and so on. So working out each of these probabilities. But that takes so much longer. It takes so much longer that it's much better for us just to spot this nice little trick that we can work out the probability of something that we didn't want and subtract it from 1.